right. All right, so this is good, cheap, and fast scaling your Selenium Grid in the cloud. All right, so just like the brief agenda of what I want to talk about, basically give a brief introduction about myself, about what Amplify Education does. I want to jump into sort of our initial state, how did we get started with Selenium Grid, and then I'm going to talk about our transition to AWS, maintaining your Selenium Grid's health, how we optimize things by adding autoscaling to reduce cost. I'm going to talk a little bit about utilizing Spot Instances, which is another way we reduce costs significantly. We're going to finish up talking about Amplium, which is a Python-based proxy for multiple Selenium grids that we wrote. Okay. So who am I? Just like Andrew said, Johnathan Constance. I'm a senior software engineer at Amplify Education. I've been there about 5 years. I'm a tech lead for our test engineering and infrastructure group. That's my website. There's my email. Feel free to reach out. Always happy to talk. And then, so what is Amplify Education? So basically, Amplify is a digital education company. We're reimagining the way teachers teach and students learn. We're sort of one of the leading education companies in the US right now. My particular part of it has 3 main products. We have digital assessments. That's like digitizing paper and pencil assessments, writing your own assessments, stuff like that. We have digital curriculum. So, a child gets a textbook instead of a child gets a tablet instead of a textbook. We also have an educational games division. So you can check out our games on the Play Store, stuff like that. We're around 350 employees, and across all these different products, we're running about 10,000 tests a day. So we're not the most massive users of the Selenium Grid, but we do need it to realistically do anything. And there's a link down there at the bottom for openings. If anything I talk about during this talk sounds really interesting, we're always looking to add new engineers to our infrastructure group, to our actual product development teams. Feel free to check it out. All right, so for initial state. So sort of Amplify's first Selenium Grid was, I think, probably the same story for a lot of people in this room. It was my desktop running the hub and the node. It was a bunch of Mac Minis on my desk. It was a really rough proof of concept kind of thing. It was just for my team. Everything was manual, which is just a massive time sink. You spend all your time upgrading browsers, upgrading Selenium, upgrading the OS, restarting things, when they get slow. You end up in situations with like hung tests. You end up with situations where just the server has crashed. You have to take care of it. It's not a fun time for anyone. So very, very complicated situation we had here. We had my laptop talking to my desktop, which then talked to the application. So clearly this is like an unsustainable situation. It's not possible to run an entire company's Selenium tests off of your desktop. So of course, we did that for 3 years. and eventually, we were able to transition to AWS. This wasn't just our Selenium Grid. This was the whole company. We all moved out of the data center, moved on to AWS, the bright new green pasture. And so one of the first things we sort of did with that is everything had to be immutable infrastructure. So if that's not a familiar term with you, it's sort of like the idea that all of your servers, all of your applications need to be immutable. You cannot change them. So it should all be scripted. It should all go out. If you need to make a change, you rebake some sort of frozen artifact. In our case, it's AMIs. And you redeploy that. You don't log into the box. You don't run yum update. You don't do any of that. It's all frozen, which is really cool for like debugging issues. Ultimately, sort of the expression that I've heard describing this is your servers need to become like cattle. Like a farmer is not upset when they butcher a cow. They can't be pets. You can't be upset that server Johnny24 has died. You need a new one. That's fine. So with that in mind, we scripted a lot of the annoyances that we found with creating Selenium Grid Hub and Node. So we use this tool called ASIAC. ASIAC is an internal tool to Amplify. It is open source. That link works. You can check it out. It's a Python command line app. It sort of controls everything we have around the area of provisioning, deploying. Pretty much anything we do in AWS is going through ASIAC, at least now. So one of the really cool things we did when we switched to AWS is using autoscaling groups. So if you're not familiar with those, basically you go to AWS, you say, hey, I want 5 of these AMIs at all times, and if they handle the cases where like sometimes a instance in AWS will die, like AWS has hardware underneath everything, that hardware breaks. When that happens, an autoscaling group makes sure that your instances come back up and you don't have any issues. The other really cool thing that we're able to do is because it's all virtualized, it's all immutable, it's all like hard-baked things, we can recreate our instances every day. That's not an issue. We can every day pull down the latest Selenium Grid code, the latest Firefox, the latest Chrome, all that fun stuff, send it out there. Not an issue. It's part of our workflow. But of course, there are some issues with this. So like I said before, with autoscaling groups, we decided, hey, let's just have 5 grid nodes all the time. That's not, great because you're not running, 1,000 tests at all times. You're running, in our particular case, we're running something like maybe 50, 60 tests at all times, just across the different teams. We have smoke tests going on all the time. We have CI tests, integration tests. And then every once in a while, you have a team with like a regression suite, which is now 300 or 400 tests in parallel. And so we sort of decided, okay, let's just build a little Selenium Grid Hub up a little bit so that when someone wants to run a regression suite, it completes in a reasonable amount of time. But of course, that means that a lot of the time, you're not using all those resources. And then, of course, we're still running into the situation where every once in a while, you might have developers from 2 different teams run their regression suites. So all of a sudden, your Selenium Grid is being hit by like 1,000 concurrent tests, and things catch fire. So we still have this issue on sort of both sides of that spectrum. And just to give you like a brief idea of how much money this was costing us, so we had the one hub. That's a C4-2X large, which is a fairly beefy instance. That was around $300. We have the 5 nodes, a little bit smaller instance, $700. That means about $1,000 an environment a month. And then we had 4 environments. We had our CI, staging, production environments. We had a deploy environment. All this stuff added together, about $4,000 a month, which is not, end of the world money, but it's also not cheap. And now we sort of ended up with this sort of diagram. So now you have your client, your Jenkins, whatever, talking to your hub, talking to your nodes, talking to your application. Hopefully this is a fairly common pattern that I think everyone in this room is probably experiencing right now. But let's talk about sort of the ways that we sort of change this up a little bit. So anyway, for maintaining grid health, sort of the 4 things that we found were very, very important. We're keeping the systems up to date. This is just true of any sort of deployed application. You need to keep your OS up to date. You need to keep the browsers, the driver, Selenium itself all up to date. We have these issues where occasionally, you'll have like a bad, a test execution. You'll have Chrome browsers lying around, not being actually used anymore. You'll have issues where, you just have to end up restarting the machine. So we've just accepted that as like one of the things we have to do every day. Every day, like I said, we bake a new version of our infrastructure, our grid infrastructure, and end up restarting all the instances with that new version. We've just sort of accepted that. To dive a little bit deeper into the handling of hung sessions. So what we do is we wrote a cron job for removing old browsers. So what we did is basically it looks for any Chrome browsers, Firefox browsers, whatever, that are older than 30 minutes on the instance and blows them away. This works out okay because at Amplify, because we want to have our tests execute as quickly as possible, we're actually making a new browser for every single test. So if you're familiar with TestNG, we're parallel by methods as opposed to parallel by class or some other structure. So basically, this means that every test gets its own browser. We never reuse a browser process. And that's worked out pretty well for us. It's made our tests a lot faster. I've open sourced this script if it's interesting to you. You can check it out at that link below. That link actually links to a bunch of snippets. There's a lot of stuff in there. OK, and then for installing the latest Selenium. So again, we're like a little shell function that knows how to go to the Selenium download page and either pick out a particular version or it can figure out and install the latest version. This gives us sort of that dual flexibility of sometimes you want to have a Selenium Grid that's just always on the latest version, so you can sort of check, okay, what broke this time? And then you also want to be able to, okay, so for the people who actually need this thing to work for surezies every time, we can say, okay, let's just stick to version 3.3.1 or whatever. So it lets you have sort of that ease of use on both sides. And again, you can check it out. It's open source. All right, and then we have, so installing browsers. This is very much the same story. So we have little shell scripts for downloading latest versions of Firefox, Gecko driver, Chrome driver. It lets you target a specific version of this tool, again. So you can say, OK, I want Firefox, I don't know, 34. Or you could say, I want the Chrome stable, or I want Chrome driver version 2.21, whatever. For Firefox, one of the cool things we did was that we added in the ability for you to say, I want the latest extended support release version. I want the latest beta, the latest stable, which was pretty cool because that let us just automatically, when the new version comes out, upgrade our grid nodes. And again, you can check it out. All right, so past that, so sort of one of the first things we did to sort of optimize cost for our Selenium Grid was to add autoscaling. So like I said before, we're actually using autoscaling groups already, but we're not actually using them to autoscale, which is sort of a strange situation to be in. So anyway, why would we want to do this? So the basic idea was we wanted to add capacity. We're running a lot of sessions. If we have our Selenium Grid sized to run 50 sessions at a time, and now you want to run 1,000, it would be a lot faster if you added some more nodes. On the other side of that, now that you've sized your thing up to run 1,000 sessions and you only need 50, you're paying an awful lot of money for stuff you're not using. So remove capacity when it's not needed. The sort of reason why we went with this instead of some other pattern, like for example, we could have gone with creating a new Selenium Grid for every single test execution. We decided that ultimately this was going to be faster and hopefully cheaper. The sort of idea was that if you need to wait for a new grid to be provisioned for every test run, and if you want to try and make your developers run those tests all the time, you're sort of introducing like a 5 to 7 minute wait time every time they want to run tests on top of the tests actually running. And that seemed like a great recipe for making your developers not want to run tests. So we decided not to do that. And then, of course, ultimately, this is to save money, and not just on the actual resource cost of having a grid, also on the resource cost of having a developer twiddle his thumbs and wait for things. So how do we go about actually doing this autoscaling? So the first thing we needed to do was find some sort of metrics. In our case, at Amplify, that's Datadog, and I'll talk a little bit about them in a minute. The second part of that was we need something to actually act on those metrics. We need something to decide, OK, now we need to add X number of instances to our grid. We need to remove X number of instances, something like that. And that for us was AstroScaler. So for Datadog, Datadog is a vendor for aggregating, analyzing, linear metrics. Basically, the way they work for the most people is they have a little agent you install it on your instance. It supports just about every OS I've ever heard of. It has a tremendous amount of built-in metrics, CPU, disk, memory, all that fun stuff. They also have support for creating monitors. So what you can do is you can have a little query that says, if this metric meets this criteria, it's beyond 50% CPU usage, something like that. You can get alerts, you can get a webhook integration, you can get an email, you can get Slack, whatever you want. You can check them out at datadoghq.com. It's pretty cool. And then for actually adding metrics, so like I said, Datadog has an agent. It's extremely customizable. It's really surprising how much you can do with it. So basically, we wrote a little integration with their agent. It's Python code. What it does is you tell it the Selenium Grid Hubs URL. It goes there, and it figures out a bunch of metrics. And I'll talk about those metrics in just a second. If you're interested, you can check out the integration there. It's open sourced along with all the other snippets I talked about. Basically, what this integration gives you is these metrics. So you're able to collect things like what is the number, type, and version of browsers that are being used on your Selenium Grid, which is always interesting when you talk to people in person and you say, so what are you guys testing with? And they'll tell you, oh yeah, Firefox, Opera, blah, 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 blah. And then you go to the Selenium Grid and you find out, oh, actually, they're really just doing 99% of their testing in Chrome. Maybe it's not as important to worry about Firefox or Opera support on the grid. You get stuff like what is the available capacity of the Selenium grid. You get stuff like what is the total capacity. And most important for us from a scaling perspective, you get the length of the queue. So how many sessions are waiting. And then like I said, so we have Datadog monitors. We have a monitor that executes this query. Basically, it generates a notification if this query becomes true. So what happens here is we're looking at the average over the last minute of the average of our Selenium Grid Hubs queue length. And then the stuff in like the squiggly brackets is like filters in Datadog. So you can say, limited it to a host class, MHC quality grid hub. At Amplify, a host class is sort of like saying service. So our grid hub service. And then look at environment CI. And if that queue length ever exceeds or is equal to 50, throw an alert. And so what happens is we really like infrastructure as code. It's really, really great to be able to see all of your infrastructure written out somewhere. Developers are not typically very interested, at least in my experience, in like going into wonky web UIs and clicking and tapping things. Most people would prefer to have everything in an IDE. So what we did is we wrote data kennel. So this is a Python command line tool for managing Datadog monitors. You give it YAML configuration file. It turns it into Datadog monitors. It's pretty cool. And what you can do is, it's open source, check it out. You can do pip install data kennel, it'll come up, and it's pretty nice. But anyway, so now we have those monitors. And what we have to act on them is AstroScaler. So again, AstroScaler is a Python application that we wrote. In this particular case, it runs on Lambda. Lambda, if you're not familiar, is AWS's serverless option. You get to do a bunch of code, upload it to AWS, and they run it for you in a Docker container, essentially. This is the link to it. Unfortunately, this link is not yet live. It'll be live, hopefully by the end of the day. Certainly by the end of the conference. It's the only one that's true for. Everything else you can click immediately. So basically the sort of workflow pattern for AstroScaler is it executes every minute. It queries Datadog for monitors. When it finds a monitor that's activated, it reads that monitor's metadata, and it executes scaling policies that it reads out of that metadata. We can talk a little bit more about that in a bit. So basically, this is sort of the reaction we had when we did autoscaling. So before on the left here, this is our environment the week before we introduced autoscaling. So you can see we're pretty much consistently at about 6 Selenium grid nodes. We have these occasional spikes up to 12. That's that midnight redeploy restart that I was talking about. And then after, I think it was roughly on Wednesday, we added autoscaling, and immediately everything dropped to like 2 nodes, 1 node most of the time, and we can see like a lot more spiky graph where when we're running those big regression suites, we add to nodes. But for the most part, we stick right around 1. So one thing that people are probably thinking about right now is when I talk about removing instances from a running Selenium grid, you're probably wondering like, how do your tests not just explode? And so the sort of solution is we have this thing called scaling protection from AWS. What this basically is a little AWS API call that you can make, and you can tell them, okay, this particular instance is actively doing stuff. Don't touch it. Don't turn it off. And what we do is we have a little cron script that runs every minute. It checks on the Selenium grid node, hey, is this node actually running tests? Is this thing being used? And if it is, it turns on protection. If it's no longer being used, it turns off protection, and bam, it goes away. No problems. One of the issues that this sort of lets you end up with is you can end up in the situation where the Selenium grid round robins its tests. It's session distribution, so you can end up with a grid with 5 nodes, each one running just 1 test. Which is not like an ideal use of your resources. If we assume that like every node could run like 10 tests, it's a bit of a waste of money to have 5 nodes doing 1 test each. But we can solve that with Amplium. So anyway, with the sort of network diagram, it's changed a little bit. So now we still have our client talking to our hub talking to our nodes, talking to the application. What's changed is now our hub is talking to Datadog. It's sending out that queue length metric. We now have AstroScaler querying Datadog, trying to figure out, okay, do I need to add nodes? Do I need to remove nodes? And then it's actually doing it. And then so to sort of give you an idea of price, so we have still the one hub, still roughly $300, but now we don't need 5 nodes anymore. We end up on average somewhere around 1.2 nodes. Most of the time it's 1. Every once in a while it becomes 5 or 6, but on average it becomes about 1.2. So you add this up across the different environments. Now we're spending about $1,800 a month instead of $4,000, which is pretty good savings. That's like 55%. That's pretty good. We could do better. So now we have Spotinst. So just as like a brief refresher, perhaps people don't know this. So we have Amazon AWS. They have this thing called the Spot Market. So basically what happens is Amazon builds a data center. They put 100 servers in it. Only 80 of them are being used. So that means they have these 20 extra servers. They can't really turn them off because they need them to be available if someone wants them. That's sort of like their whole deal. So what they do instead is they have this thing called the spot market. So they say, okay, these 20 servers, no one wants to buy them for the 10 cents an hour it costs to run them. What are you willing to pay? And you can place a bid. You can say, well, I'll give you 5 cents for those servers. And Amazon can say, deal. But it's like a market. So basically, prices can rise and fall with demand. You can end up in a situation, like the sort of classic answer is Netflix is all AWS. So when Netflix releases a new Netflix original, the spot prices skyrocket. So you lose all your spot instances whenever House of Cards comes out, basically. So the way you sort of end up dealing with that is, your bid is no longer sufficient. Amazon says goodbye, and they take away the instance. You're supposed to get like 2 minutes notice. In actuality, you get however much notice they can give you. It might be 10 seconds. So this is a bit problematic. So sort of our answer was to use Spotinst. So Spotinst is another vendor, and what they do is they sort of automate the spot instance market for you. So you can go out to Spotinst, you can tell them, okay, I'm interested in C4 X large nodes. I'm interested in having them in the west coast of the US. And basically, they try and get you the cheapest price. They automate all of the bidding aspects for you. They automate a lot of the distribution. Basically, you just tell them what they want, what you want, and they get it done for you. They sort of fall back automatically to using on-demand instances. So when Netflix comes out with the new House of Cards season and all the spot instances go away, Spotinst automatically switches you over to on-demand instances so you can keep working. Another really cool thing that they do is they try to use machine learning to give you advance notice of these situations. So, obviously, Netflix is not the only example. That's a fairly predictable one. You just look at the calendar for new releases. They use machine learning to figure out other things, other patterns. And they try and give you more like 30 minutes advance notice that, hey, this thing's probably going to go away, instead of the AWS 2-minute promise. You can check them out, spotinst.com. Really great. So the sort of problems with the spot market still, so like I've said, we have our AstroScaler solution. We had to update that to work with it. That's, oops, we had to do that. Spotinst sort of like acts as like a wrapper around AWS. So it is a new API. You do have to worry about interacting with them. But again, like I said, we have that issue again with, even with Spotinst, we could have 30 minutes notice, but we still have to worry about, what happens if this instance just disappears. This could happen. So our sort of solution to that was Spotinst has this thing called instance protection. It's just like the scaling protection that I mentioned earlier. So what you can tell Spotinst is, okay, I understand that this thing is going to go away in 30 minutes. Just give me time. Let me work it out. So we expanded that protection script that I talked about earlier with the scaling protection to also set this Spotinst API call that turns on instance protection for them. So now if Spotinst says, okay, hey, this thing's going to go away in 30 minutes, we can say, okay, understood. Let me finish these tests really quick. And we can sort of take the grid node out of service in a slightly gentler way. But ultimately, I sort of think that we accepted just as an organization that you have to worry about retrying your tests. You know, tests are going to fail, be it for infrastructure issues or something else. We just accepted that we have to retry them. So sort of update you on sort of what the diagram looks like now. We still have everything else, but now we've added Spotinst. So now AstroScaler talks to Spotinst. If it wants to scale up or down the Selenium Grid nodes. The other addition we have here is Selenium Grid nodes now have a little cent sign because they are so cheap. But how cheap? So now our 1.2 nodes that we were running, those are actually $41. So we cut that roughly by 2/3. And now we're costing about $1,300 total per month across the 4 environments, down from our original $4K. So about a $500 drop across everything, which is pretty good. But we can do a little bit more. So with Amplium, sort of the sort of questions we were asking ourselves is, you know, what are some of the issues with the Grid Hub as we see them today? So it's a single point of success. You cannot have multiple Selenium Grid Hubs. The architecture just doesn't tolerate that. You have the one big hub, and you have a bunch of nodes that talk to it. Because it has to be this one big hub that you can't really scale, you have this usually very high resource cost. So like I showed in the previous slide, at this point, the hub is like most of the price of our Grid Hub infrastructure. And then you cannot scale with load. So if you ever exceed your really ridiculously oversized hub's capacity, things catch fire. And the other issue we had is that it's very hard to do connection draining, almost to the point of impossible. It's not really meant, in our opinion, to handle this case of how do you get rid of nodes, add nodes live. You can't really do that. So what we did was we made Amplium. So Amplium is a load balancing proxy for multiple Selenium Grid Hubs. It's capable of scaling up and down to handle additional load. You can have 1 Amplium, you can have 1,000, doesn't really matter. What it does is it hooks into Zookeeper for automatic discovery of Selenium Grid Hubs. I'll talk a little bit more about that. Another thing that we built in that we thought was really cool is that it supports sending sessions to SauceLabs out of the box. You give it a little bit of configuration and does it. It's open source right now. You can go to that link, check it out. It's a Python app. It's a WSGI app, so you run it behind something like Apache or Nginx, something like that, and it just works. Sort of give you like more of a rundown of like what's going on behind the scenes with Amplium. So it runs on Amazon EC2, which is like the traditional virtual machine offering. It's fronted by an elastic load balancer. So you can add new Ampliums, you can remove Ampliums. It's all handled seamlessly by that. We use DynamoDB, which is sort of like an AWS version of MongoDB. It's like NoSQL database. We use that for storing the state information. So stuff like that is, when Amplium has to write and make a new session on a new hub, it sort of stores that, okay, this particular session ID maps to this particular Selenium Grid Hub, and it sort of looks it up every time you have follow-on calls. And like I said, it uses SmartStack for service discovery, Zookeeper. And sort of to just jump into like sort of how the different things of Amplium work. So we have load balancing. So what sort of happens is when a new session comes in, Amplium queries for a list of all the active Selenium Grid Hubs out of Zookeeper. Amplium sort of checks out how much capacity is available on each Selenium Grid Hub, and it sorts them from most capacity to least capacity, and then from least to most available capacity. And then, so sort of the idea with that is we wanted Amplium to not round robin. We wanted Amplium to sort of fill up the first server and then move on to the second server and then the third in sort of a predictable fashion, so that we could feel more safe about removing the third server when nothing's on it, because now we know that everything will go to the second server and so on and so forth. So this is sort of to make it easier to get rid of grid nodes that you're not using anymore. All right, and then we also had to worry a little bit about queuing. So when you talk to Amplium, what it first does is it checks, is there available capacity on all the grid hubs that I know about? If there's not, it keeps looking. And then eventually it either finds that, okay, I have a grid hub with available capacity, or I don't. If you don't, you return an exception. You get like a nice little WebDriver exception message that says Amplium, no available capacity, which is nice. you can pull that out and do some sort of special handling around that. What we did here is we made the time to wait configurable. So right now it defaults 3 minutes. It's just like the Selenium Grid Hub. You can set it to -1 and have it be infinite. You can set it to any sort of integer of seconds you want it to be. In our experience, autoscaling sort of operated fast enough that 3 minutes worked well for us. We didn't really have to worry about the exceptions, handling them, stuff like that. After 3 minutes, either a hub has come up or, well, usually it's come up. Okay, and then, so I sort of briefly mentioned that we had like this little SauceLabs integration. So basically, why SauceLabs? Why are we even talking about them? Like I said, we have like an educational games division, and they do mobile devices much better than we ever could. We tried. Basically, we had to like hire a guy to just sit in a room and restart iPads all day, which is like a really bad thing to pay someone to do. They're not happy. You're not happy. No one wants to do that. So we said, okay, SauceLabs. Maybe that price tag makes sense now. So we went out, got a little subscription. What you can do with Amplium is you can set this configuration for SauceLabs. Basically, you give them the credentials, the username and password. You just do it on Amplium. And then when you're actually sending requests to Amplium, you can just say, Amplium use SauceLabs as a desired capability in your tests. And if that's set to true, Amplium forwards it onto SauceLabs. This is kind of cool because now you don't have to worry about having your SauceLab credentials like copy and pasted across like 8 different teams. You can just have it in Amplium, and if you ever need to change them or anything like that, it's a lot easier of a proposition to change it one place than 10. Okay, and then so sort of the next steps for Amplium. Like I said, right now it just uses SmartStack, which is like Zookeeper for service discovery. That's like not the most widely used stack in the world, so interested in adding more capability for it to do more service discovery instances. I would like to have it do more inspecting and matching of capabilities. So right now, Amplium sort of presumes that all of your Selenium Grid Hubs are homogeneous. It doesn't understand the situation where you might have a Selenium Grid Hub that is IE, and one that is Firefox, and one that is Opera. It sort of just assumes that everything's the same. So adding that feature would be nice, because I'm sure there are people in this room who do that. And then we've talked a few times about session draining. So it'd be very, very cool if Amplium could inspect a grid hub and say, oh, okay, you're going to be leaving us because of the spot market, or we want to redeploy a new version of you. Have some sort of mechanism that lets us safely remove and stop sending sessions to a grid hub once we want to get rid of it. And then sort of to show off the full diagram of what's going on now. So now we have Amplium sort of fronting a bunch of Selenium Grid Hubs. They have there's sort of 2 forks you can go. So you can either go from Amplium to SauceLabs, or you can go from Amplium to the Selenium Grid Hubs like normal. It has DynamoDB that it's using for doing that session checking that I was talking about before. That's pretty much it. So let's take a look at like what this has done for cost. So now with Amplium, what we're doing is spending about $15 or so a month per environment. Now we still have the 1.2 nodes, so those are back to being the expensive part of the equation, which is sort of where you would expect them to be. And now we're sort of sitting on this situation where across our 4 environments, we're now spending about $230, down from our $4,000 a month. About a 95% cost reduction, so we're pretty proud of that. And that's it.